We'll be discussing how to find the expected values in a series circuit today, and we will be using a purely resistive circuit. We'll be using the values for the resistors will be 50, 25, and 5 ohms with 48 volt DC as our applied voltage. First thing that we need to do is find the total circuit resistance, and to do that in a series circuit, the sum of your individual resistances equal the total resistance. So we'll add in our 50, our 25, and our 5 ohms, and that's going to give us 80 ohms resistance. The next step we'll do is to find out the current for the circuit. We'll take the total applied voltage and divide that by our total resistance of 80 ohms, and that's going to give us 0.6 of an amp, or we can also say 600 milliamps. Now in a series circuit, the current remains constant through all components, so we'll just simply fill in the rest of these values. Our next step is to find the individual voltage drops, and to find that we'll take the resistance of the individual resistors and multiply them by the current for this circuit. That'll give us a 30 volt drop for the first one. For our second one with 25 ohm and the 0.6 of an amp, give us a 15 volt drop. And for our third one, we'll use the 5 ohm value and the 0.6 of an amp, and that is going to give us a 3 volt drop. And it's always good to check your work. In a series circuit, the sum of the individual voltage drops will be equal to the applied voltage. The next step we'll do is to find the power for the circuit. That's the amount of work that we can do. And to do that, we'll take the 48 volts applied and we'll multiply that by the circuit current. And that's going to give us 28.8 watts. We can also find the power dissipated by the individual resistors, and it's quite similar to it, but we'll use the voltage drop of the individual resistors to do that. So we'll take the 30 volts times the 0.6 of an amp, and that is going to give us 18 watts. The second resistor, we'll use the 15 volt drop, multiply it by the 6 amps, and that's going to give us 9 watts for that resistor. And then the third one with the 3 volt drop times our current, and that is going to give us 1.8 watt for that resistor. And again, you can check your math here by adding up the sum of the power dissipated by the individual resistors, and it will equal your total wattage for the circuit. What we'll do with these expected values is use them as the baseline for when you go out and measure the live readings on the circuit, and use that to tell whether you're within range, and if you need to go look further into the circuit there or move on to a different part. Thank you and have a good day.